Yeah, I guess technically MIT time is 9:05, so we're on time. So welcome everybody to the Jump Developers Workshop or Meetup, depending on who you're talking to. Same thing. So I guess it's like, if you're asking for reimbursement, call it workshop. Otherwise, just call it meetup. So I'm basically just want to do some quick introduction notes before we get to the actual talk. So almost like master ceremony or something. So let me start first by giving some thanks. So let me thank the organizing committee, basically Miles, Joey, and Chris, which are the persons that you should bother if you have anything to do. You need anything, just go and talk to them. And Jen Chalice, which actually will has been in charge of doing more logistics to make everything work. So thanks to her in particular. I also like to thank our sponsors. So this is being sponsored by the MIT Management Latin American Office. I'll tell you a little bit why Latin America and Jump. I'll explain about that a little bit when I talk about some news, but they're the ones giving us some funds to do this and to do more things down the road. To our speakers, I guess you're all here, so I guess I listed, I'm not going to thank Chris, Joe, and Miles twice, so I didn't list them because they basically didn't fit. I was going to take a picture because the next thank is basically the general audience and the broad Julia community. So I guess we have a photographer that's going to take some group pictures, so I'll add it afterwards when the slides are posted, and so basically I'm cheating. And that's about it. So I just sort of for the record, I'm going to give a quick introduction of Julia and Jump. And it's in parenthesis mine, because I would say like all the hype is mine. I'm the hype man here, so all the hyperbole, it's due to me, not to anybody else. So, and all the criticisms of other software as well. Let's say it's my responsibility. So I guess the way I like to paint this is that there's been 20th century modeling languages for optimization. And basically I divide them into two categories. So either very user-friendly algebraic modeling languages and commercial open source C or C++ interfaces. I'm not sure if there's any other languages that are primarily in, that are not, but I guess it's like C#, there's some interfaces and whatnot. But basically the idea is that within the algebraic modeling language, you have things that are easily accessible, and there's two big groups. I would say standalone modeling languages like GAMSA and AMPL, which I usually thought it was like, oh, these things are slow, but I guess like looking more deeper, at least in the model building, they're actually quite fast. So they're useful as long as you're just building a model. Now, if you really want to do anything else than just build a model and solve, you start running into trouble because they're not really built in a general purpose language. So that's where Pyomo and CDX and other tools that are built on top of general purpose language like MATLAB and Python come into play. And they're really good in the sense that they're versatile. Now you can really do the composition, embed your algorithm, your solving of an optimization problem inside a bigger algorithm. But unfortunately, they're usually very slow, primarily because of the issues with the programming language itself. Or you have to jump through hoops to actually make it fast in practice. On the other hand, the commercial and open source C++ frameworks are really powerful. They're built in a general purpose language. You can do pretty much whatever you want. You can sometimes, at least for the open source or the kind of open source things like Skip, you can modify it and really change a lot of it. But unfortunately, they're usually somewhat complicated. So we had this sort of the economy here that would really like to have everything, and I guess that's sort of like how Jump got started. Same way as Julia got started. Basically, a bunch of greedy people said we want to have everything. So Miles, Ian, and Joey just decided like, we should be able to get everything done. Have our cake and eat our cake and have it too. To have speed, ease of use, be embedded in a general purpose language, and so on. Now remember, I think probably it was 2012 that I talked on the phone with Miles. I was convincing him to try to come to ORC, and he mentioned Julia, and I'm like, what is this thing? And it's like I wasn't too convinced. It's like, yet another programming language. And maybe it took about a year until I was completely sold, and I basically switched all my research, of my research now is based on Julia and jump, and I would say it's been for several years now. Definitely, I was an early adopter, mainly because everything that something broke, I could actually bug people directly. I think somebody needs to definitely teach me how to do pull requests in Git, because my pull request was basically sending an email to one of these guys. So I should change that. I guess you already know that part of the reason why Jump's working so well is because of the community. We have a very big software stack or software ecosystem with different modeling tools and interface solvers and so on. And I guess that's where the group picture will go as well. And basically we're all sort of like under this JuliaOpt. I'm kind of interchangingly used Jump and JuliaOpt to a certain extent. I guess there is convex.jl. We're kind of centered more around Jump, but there's also MapPro basic interfaces, and I would say that we're not necessarily thinking that we're going to be stuck only with Jump in the future. It's really just Julia optimization. But I guess for now we're more centered in Jump. Just some milestones that these I stole from one of Miles' slides. So basically everything's been growing. Documentation hits have been growing, sustainable. There's some interesting jumps around here that I think I have an explanation for, and I'll give you a possible hint about what they could be in a couple of slides. It's been used in a lot of universities now, and like a lot of courses now are based on Jump, and I think here we're probably not even counting things that are pure Julia. I'm basically just counting things that in some way or form use JuliaOpt. If you know about any courses or universities that are using Jump and it's not here, please let me know. And so it's becoming pretty much the gold standard in courses of optimization, and I would say in research, and hopefully soon in practice too. There's some, I guess, nice examples of use of Julia optimization packages in the literature. I picked the ones that in some sense are sort of surprising or have names that kind of sound fancy to me, so computational biology and chemistry, PNAS survey, fusion plasma. So basically I picked names that I couldn't understand and looked fancy and serious. So here's 3 examples. There's a ton of other ones that are like we've been using that we'll recognize fairly easily, but there's a lot of work on people that in some sense are not necessarily so connected to Julia or to optimization, and are actually finding a good way of actually applying optimization techniques into their particular domain, thanks to the ease of use and power of Jump. The not so serious application I just wanted to mention is at one point a colleague, Tawhid Simon, and his student David Scott, who was an undergrad at MIT, they were thinking about could we use analytics to actually try to play DraftKings and win in DraftKings? And they had some ideas on how to do it, and when they presented to me, I looked at it and I was like, this is exactly something you could solve with an if solver fairly easily. So, and I was like, well, how do we build this? I basically said, go read the Jump documentation, build it, and the student went, built the model pretty quickly, and it worked. And we actually started winning fairly sustainable. At some point, DraftKings started changing the rules. We got invited to VIP events. I think they went. Tawhid and Scott went to see a game in Gillette Stadium and so on, and basically it was working really well. So we posted the code in GitHub, and a lot of people got really interested on using it. So we both presented on last year in Sports Analytics, and Tawhid presented again in Sports Analytics conference this year. And there's some right around that time, there's some sort of sharp increases of the Jump documentation. I have no idea if that's actually completely accurate, but it feels like a good story. It's how do we get people hooked on optimization? It was through Jump and basically convincing them they can make money in DraftKings. And I would say on the other hand is I really like this quote because I think this is the only time I'm ever going to show up in Reddit and in our math was because of this. So we're for a little time, because you can't really see, we were number 1 for a little time. It lasted an hour, so I could take the picture exactly at the right moment where it says number 1. So I guess I'm not sure if the comments mentioned Jump. Do you remember it, Miles? But even if they don't know that we're using Jump, the people that were downloading code, and people have downloaded code, modified for baseball, they're using it and so on, they might not even realize they're using Jump, but they're using Jump. They're using optimization techniques almost without even noticing, because they have the code, it was very easy to modify, and it works. both with commercial solvers and open source solvers. So that's my quick introduction. So I just want to give you now a few news about what's going on with JUMP. Not Miles will talk more about what's going to happen with the workshop itself. You've probably heard, but last year JUMP won the ICS prize from the Inverse Computing Society. I believe it was the first time papers only by students actually won this award. So it's not a student paper prize; it's an actual paper prize. And the committee was actually quite happy. I was really happy reading the citation. It was actually, they really got what was going on, and basically is using the advanced functionalities of leveraging the advanced functionalities of Julia to actually get a system that's easy to use, as easy to use and has and as fast as commercial tools, but actually has unique features that are definitely not present in any of the commercial tools. And it's because of these two papers, and it was kind of funny that the SIME review, I picked just SIME review from my mailbox today, and this is a SIME review that actually has the JUMP paper. So that was kind of nice. There's also, the Julia paper also showed up in SIME review recently, so I guess we're now going really mainstream on, at least on the academic front. The other news is Dr. Lubin here actually defended last week, last Monday. If you missed, so we were streaming live as well, so if you missed it, the link's over there. You can actually see his defense. It was about mixed integer convex optimization, not really talking centrally about JUMP, but basically almost everything except theoretical results was based on JUMP. Pajarito is based on JUMP and Julia and so on. So I guess a little bit more technical, but definitely we're seeing. He is moving now to Google Research, so, but we're not losing him. He'll remain very involved in JUMP. However, I won't be able to boss him around as much as I would like to. So I'd like to welcome Jared. So I need somebody new to be able to boss around. So Jared is now basically joining us as it's been a pain to try to figure out what his title is, but I think I was looking at the offer letter, and it's Sponsored Research Technical Staff. So he's the JUMP Sponsored Research Technical Staff. He'll be here on Wednesday. He's not here now, so I feel very comfortable saying, if you have any questions or anything you need help with JUMP, or you know anybody that needs help with JUMP, put it to Jared. He'll take care of everything. So basically, I'll be in charge of doing internal development, but also all the extra maintenance stuff that we need to keep JUMP a little bit more sustainable. So in that sense, so we're trying to figure out, I guess one of the points of this workshop is having JUMP 1.0 out, but we're also thinking about the future, how are we going to keep this sustainable, and at some point we'll send a grant, a proposal with Alan about Julia and JUMP, and they asked specifically this. And it's like, this is the idea they came up with, and it's basically the three pillars of sustainability. So we divide it into sort of academic endeavors, so academic institutions that basically get grants for work in a particular optimization project, and basically that funds students or people to actually do development of JUMP and Julia. The broader community, which I would say is the key to why Julia and JUMP works, is just like people that want to use it and like do a pull request, an actual pull request, and fix things and get incorporated. And the extra part is the commercial side. So there's a lot of questions on the long-term sustainability. Some people just like want support or want something more stable or basically want to be able to pay somebody so they can yell at them when something doesn't work or something breaks so it gets fixed. So for now, it's been mostly Julia Computing. We sort of have a lot of pledge of support from Julia Computing to see where we go with JUMP in the future. So we're not really sort of actively thinking about anything commercial, but it's definitely a possibility. We don't know exactly what the model is. There's a lot of interaction, so I would say Jared technically will be on the academic side, but we're trying to get him more as an engineer than a PhD student so we can give sort of that commercial stability to JUMP. So there's a lot of interplay here. I guess funding came from MIT Sloan. You could put MIT Sloan also perhaps commercially. We're using JUMP in the Master of Business Analytics, which I guess it's sort of like, in some sense, commercial. So maybe Sloan will have some vested interest on actually investing in JUMP and helping develop it. And so we're exploring all the opportunities. The main thing is that I think we definitely want to remain open source throughout, at least primarily. So I don't know exactly what primarily means, but perhaps, let's say, there's a software company, let's say Cplex, Groovy, Mosaic, want to do something. We're not going to force them to like open source everything if they don't want to. But I'd say the core will remain open source, but there's questions of opportunities. Perhaps I'm thinking Julia Computing at some point had this Excel link that they have to be able to use Julia, which is something, I guess, it's like nobody's going to want to develop it, but there's people that might be willing to pay for it, so those are things that maybe will remain not open source. But I'd say like everything that we would want to use or that people that are using Jump right now would want to use will likely remain open source, and the things that might remain closed source will be things built on top of Fade interfaces that nobody wants to build, but somebody wants to pay for them. So just as an open possibility. In that sense, the other news is, so part of the reason why this was funded by the Latin American office from Sloan, which is actually based on Santiago in Chile, was to basically try to bring more of Julia and Jump to South America. So I'm going into Santiago in August, and we're going to look primarily in Santiago, but the idea is to try to get more of the Latin American community to actually participate in Jump, either collaborating from the academic side, from the community side, but potentially from the commercial side, the entrepreneurial side. I mean, it's sort of so easy to build new models and use advanced tools using Jump and Julia that there's a potential there for startups to actually start doing derivative products, and we're trying to explore that. There's some funding in Chile for startups that we're looking to tap. There's this Chile-Massachusetts initiative, which is collaboration between Massachusetts and Chile for entrepreneurship, energy, education. Those are the focuses. We will see some applications of energy tomorrow from Brazil. So I think there's a lot of opportunities there. In particular, the community in Chile is in Chile and South America, they're very mature from the perspective of software and optimization in particular, but there's a lot of economic incentives to actually use open source products instead of commercial solvers or commercial products that are too expensive. So, yep, I think that's everything that I wanted to talk. I had some cool animations, but we'll leave that for afterwards. I want to give the last 5 minutes for Miles to start early and sort of give us an overview of the workshop. So with that, again, thanks for being here. Welcome, and let's hopefully have a great week.